Hello, everybody. How are you all? I hope you went through the last session and I think it was beneficial for you. You understood what are computer languages and all that. And we just learnt about one type of computer language that was low level language. Okay. Now, welcome to the next session. We are continuing with the first chapter and we are going to deal with high level languages. Okay, the session is very small because I want you to take slowly only because maybe this is little difficult for you people to understand because it's more of theory and I know you all will not sit for too long in front of my video. So I thought I'll just cut short into small videos and then I shall explain to you. Okay, so today we are going to learn about high level language. In the last session, we saw that a computer language is divided into two types, mainly low level language as well as high level language. And in low level language, we learned that there are two types. One is machine language, which uses binary form, and the other one was assembly language, which uses an assembler. So we learned the limitations, we learned the advantages of both machine language as well as the assembly language. I hope it was clear for you and I hope you have also taken down the notes side by side when the slides were taught for you. Now we are going into the second type of computer language, which we call it as high level language or HLL, which we are all going to deal with also. Okay, so now I take you on to the slides. Okay. So we move on to the second part of Introduction to Object-Oriented Programming Concepts. Here we are going to deal with high-level language. And we have seen in your low-level language, there were some limitations. What were the limitations? The user had to know the binary form or the mnemonics, and it was very difficult for the person to remember it and write it, right? So to overcome that, what did the experts do? Experts, they thought of developing another language which uses English-like words, like English phrases, clear? So that it is very easy for anybody to remember. So in your high-level language, it's not in the form of mnemonics or operational codes or binary form, but here in your high-level language, you are using English-like words and mathematical symbols. You know, English-like words means simple English words. And mathematical symbols means like we have plus, minus, asterisk for multiplication, division. So like all this, the mathematical symbols were also used in your high-level language. Even the user could use his own native language. And here, since these English-like words to write a program, it was more easier. The style and the context was very easier compared to your low-level language. Clear? And one more disadvantage we learned in your low-level language was that your machine, it was machine dependent language. Means wherever you wrote, it has to be run in the same type of machines. But here in your high-level language, you are writing the code and this code could be run on any type of machine. That is why we call it as machine independent language. Then, easier to understand and develop the program logic. What do you mean by logic? Logic means idea. Suppose somebody is telling you, you make a software for me for a supermarket, right? So how will you create a software? You should know what all things happen when you get into a supermarket, what all they do, all the details you must gather, and then you should write a coding so that it comes out as a best software. So logic, the idea should be there. So since they are English-like words, the idea also came out to be more easy. Then, since it was English language, and the user who wrote the language program could understand what he has written, not like ones and zeros or mnemonic codes. If there was any error in the program, the detection, and after detecting the error, the correction was made easier, right? And these are the main advantages of your high level language. One is it uses English like words or phrases and mathematical symbols. Second one, since it was English like words, it was easier to learn. Third one, it is not dependent on the machine where it was created. It could be used on any type of machines. Fourthly, and the logic, the idea to write the program was quite easy because it was not in the form of binary numbers or mnemonic codes. Since the user knows English or his own language, your detection of any error, once you start executing it, there was an error, then that error was very easily understood and it was corrected. Okay, some of the examples of your high level language are basic. I think, I don't know whether you have learned basic in your 6th standard, basic, C, C++, Java, Python. All these are examples of high level language. So this is where you're going to learn on Java. So Java is a high level language. It uses English like words. It also makes use of mathematical symbols. Okay. So you are all going to learn a high level language. Which is the high level language which you are going to learn? Is Java programming. Okay. So now we are going to do what is a major disadvantage then. So if I am going to write in English, how will your computer understand? This point we discussed last session. So if I am going to write in English, will your computer understand English? No. Machine code of high-level instructions might be less efficient than the machine code generated from assembly-level instructions. The coding will be less efficient than compared to your mnemonics or your binary number because you are writing in your system in your English-like language. And what happens? Because you are going to write in an English language, the machine cannot understand. Am I right? When we learned machine language, machine could understand. But when we went into your assembly language, it could not understand. So we there went in for something called assembler. The same way, here also in your high level language also, your English like words were not understood by the computer. So what you needed? You needed again a translator. So the translator, what that software will do? It will convert the source code into machine code. Here, there is a term called source code. What is source code? The coding or the program which you write in your English-like words, that is in your high-level language, that coding, you call it as source code. Right? So when after 2 or 3 lessons, you are also going to write programs. So whatever you write as Java programs, we call it as source code. And this source code will be converted into a machine understandable form, that is binary form. And that binary form, you call it as machine code. So whenever you are making use of a high level language, you require a source code which has to be converted into machine code with the help of a translator. So there in your assembly language, we learned on something called assembler. In high level language, there is a translator and that is in the form of compilers and interpreters. So the translator in a high level language are of 2 types. One you call them as compilers or interpreters. Clear? Why do you need the compiler or an interpreter? Because the language what you are using are not binary form. You are using English words. Your computer doesn't understand English. So you have to translate them. To translate them, you need a translator. So that translator could be a compiler or it could be an interpreter. I hope it is clear, right? So now we are going in detail about this compiler and interpreter. So here is your definition. A program in HLL needs to be converted into machine code so that the computer understands the instructions for processing, right? Suppose if I say system dot or print a plus b, so computer will not understand what is print, what is a, what is b, your computer will not understand. So there will be a translator to tell, okay, you have to add this two and then print. Okay, the program then, if the program contains any error, it must be corrected for successful execution. So what does this compiler or an interpreter will do? It not only converts the source code into machine code, but also checks for is there an error. Clear? So whenever you are using these computer languages, there are certain rules which you have to follow. Like when you are using your English language, I cannot say I, instead of telling I am a girl, I cannot say I is a girl. Will you say? No. There is an error there. What is the error? I always goes with am. Am I right? So that is a error which you made while telling something in English. So that will be corrected. Similarly, when you are writing a computer language, a HLL, it has to be converted. It has to also checked and then only conversion happens. This checking of if there is an error, okay, is that error checking is also done by your compiler or your translator. Clear? This, it can be done in two ways. That is, one is compiler, the other one is interpreter. Now, your compiler, what does it do? Compiler has got its high level language. This will be converted. So, he is the translator, will be converted into machine language. Okay. So, compiler, what it does is converts high level language into machine language. Like in the last session, I gave you an example. If I am going to speak Spanish and if you don't understand Spanish, what will you do? You will have a person sitting in between to translate my speech into your understandable language. So that person, what he will do? He will also check for any errors, grammatical errors, and then he will correct it. The same way it is done by compiler and also by interpreters. So HLL, high level language, interpreter converts it into machine language. So what they do is a source code. Source code means whatever you are writing, that is being converted either by the compiler or by the interpreter and is given to a machine readable form, that you call it as object code. Now, how you differentiate between a compiler and interpreter? Here they have told either it makes use of a compiler or it makes use of an interpreter. Both are doing the same function. What is their function? Translating the source code. Then, what makes them different? Okay, what is the difference between compiler as well as interpreter? Both are doing conversion. Am I right? Both are doing the conversion from source code back into the object code. Then, what makes them different? The way they convert is different. How the compiler does the conversion and how interpreter does the conversion, both are different. They are following two different methods. So that makes them different because both are translators. The method they follow in conversion makes the difference. Okay. Now we'll see what does a compiler do. Compiler will convert the whole source program, means the program what you write, into the object program in one stretch, once. Then what is the interpreter doing? Converts the whole source program into the object program one line at a time. Fine. So I'll go in detail into it. Now, suppose you are writing a program for 10 lines. How many lines? Just 10 lines. You have a program written for 10 lines. And you are writing it in, say, Java. So Java uses English-like words. And what you're going to do is, you have to convert that into your object code or machine-readable form. So what happens if, for example, I'm using a compiler. What does the compiler do? The compiler will convert, first check for all the 10 lines whether there are no errors. There are no errors. If there are no errors, the whole 10 lines will be converted into the object program. If there are an error, then after converting them, it will come out and it will give you a message telling there is an error maybe at line number 3 or line number 5. Are you getting it? The whole 10 lines are converted into object program and then it comes and gives you the error telling these are the errors. Then the same 10 lines of programs, if I am using an interpreter, what will happen? I said there are errors in line number 2, line number 5, line number 8. So what it will do? First it will read the first line. After it reads the first line, it checks for if there is any error. Okay, no error. So it converts into the object code. Then it reads the second line. When it reads the second line, there is an error. Immediately what it will do? It will stop the translation. It will come and give you a message on your screen. There is an error in line number 2. So what you have to do? You have to check the error, correct it, and then again you put it for translation. So again it does line number 2. Okay, fine. It gets converted. So similarly, line number 3, no error. Line number 4, no error. But when it comes to line number 5, what happens? There is an error. It stops the conversion, comes and gives you a message telling line number 5, there is an error. So what is happening? Every line is being checked. If there are errors, it stops further conversion, gives you the message, gets it corrected, then only it goes into the next line. What happened in a compiler? It went in for conversion. Wherever there was the errors, it was shown at the last. Okay, line number 2 error, line number 5 error, 8 error. We had to go into line number 2, 5, 8 and then correct for errors. Again put it for conversion. I hope you are getting things. Now, if I use a compiler or if I use an interpreter, which will you think will be more easy or beneficial? Which will be beneficial? Or which will work faster? Of course, compiler will work faster. Why? Suppose if I have 1000 lines of program, right? All the 1000 lines will be converted at a stretch, and then whenever there is an error, those lines only will be shown for errors. That only I have to correct it. Imagine the case of an interpreter. 1000 lines, one line corrected, second line corrected, third line error, stopped the error, and then came out, we had to correct it, then it goes into third line, fourth line, so it will have to reach till the 1000th line. So how long? It takes much time. I hope you're getting it, right? So that means your interpreter execution time is small. That is, it is very slow. Whereas in compiler, your execution time is faster. That is the main advantage of a compiler compared to an interpreter. But on the other hand, there is one more thing. If I'm talking about the 1000th line, right? If there is an error in line number 2, then line number 656, compiler, what I have to do? I have to go and search for the second line. I have to search for the 656th line. So there what happens? You're finding out the errors. Detection of errors becomes little bit time consuming. Am I right? There is an interpreter. What happens? Okay, second line, I know there is an error. So unless I correct it, it will not go into further. So here in an interpreter, your detection of errors becomes easy. So both compiler and interpreter has got an advantage and a disadvantage. Compiler, the advantage is that compiler works faster, whereas interpreter only line by line, so it takes time. But in compiler, the disadvantage is error detection. We are not writing a software for just 4 or 5 lines. It includes many number of lines. So in interpreter, error detection is easy. But what happens? Slow it goes. Fine. So now we'll say, I hope you understood. Now, in compiler, displays the errors for the whole program together after completion. As I said, 10 lines are there, checks for all the 10 lines, and wherever errors are there, that will be displayed. But here, displays errors one line at a time and only after debugging. Yeah, new word. What is debugging? What do you mean by bugs? Not that insects. Bugs in our software term means errors. Then what is debugging? Deleting the errors. Okay? So displays errors one line at a time, and only after debugging the control goes to the next line. So you have translated only 10 lines in an interpreter. The 10 lines are error free. Okay? So this is the main advantage as well as disadvantage of both a compiler as well as an interpreter. So compiler and or an interpreter is required whenever you are making use of a high level language. I hope. Did you break your heads? No. Very easy. You listen to my words, then it is very easy. Okay? So with this, I just stop this session on interpreters and compilers. As I said, I don't want to break your heads so much. With this, I just stop, and please go through these slides, take down the notes. It becomes easy. Okay. So next session, I'll be teaching you on the different types of high level language. Okay. So take time, go through it, understand. If any doubts, please do refer back to me, and have a nice day. Thank you for watching.